So you can see that we've updated the table with a volume of 246.87 centimeters cubed when our radius was 1 and our height was 78.62 centimeters. Next, we're going to take a look at the situation when we had a radius of 2 centimeters, and we'll calculate the height and the volume for that cylinder. So with a radius of 2 centimeters, we have our surface area formula of 2 pi r squared plus 2 pi r h, and we're going to substitute in the values that we know. We know that the surface area is fixed at 500. We're going to substitute in pi as 3.14 and our radius of 2. Second part of the equation, we have pi again, so we're going to plug in 3.14, the radius of 2, and we've got our h, our height, which is unknown. If we simplify this a little bit, 2 times 3.14 times 2 squared is 25.12. 2 times 3.14 times 2 times h should give you 12.56 h. Now we need to try and get this h all by itself or isolated. So the first step is to subtract this 25.12 from both sides. And when we do that, you should end up with 474.88 equals 12.56 h. Now we'll rearrange this a little bit so that we can solve for h, and we need to divide by this value in front of h, by the coefficient. So we're going to divide both sides by 12.56, leaving h all by itself, and when you divide 474.88 divided by 12.56, you end up with a height of 37.81 centimeters. So we've updated the table with our height of 37.81 centimeters when our radius was 2. Now we're going to be able to calculate the volume for this cylinder. So we've got our volume formula of pi r squared h, and we'll sub in 3.14 for pi, our radius of 2, and our height, which we just calculated to be 37.81. When you multiply all those values together, 3.14 times 2 again, times 37.81, you should end up with a total volume in this case of 474.89 centimeters cubed. So in our table now we have our volume of 474.89 centimeters cubed when our radius was 2 centimeters and the height was 37.81. Your task is to complete this table, calculating the heights and the volumes for each of these situations, a radius of 3, 4, 5, 6, 7, and 8. What we need to do is try and figure out which of these dimensions gives us the maximum volume for this can or this cylinder. The maximum volume is what we're looking for in this column.